In this video, I'm going to go through the Lesson 4 homework questions for reverse tabular in case you had any questions. So for the first one, we want to use reverse tabular to find this quotient, dividing this degree 3 polynomial by this degree 1 polynomial. Well, the first thing I could do is I could set up my box. And I'm going to put that bottom part, the divisor, on the right-hand side. Because remember, when you're multiplying, your factors go right here and right there. So we already know one of the factors. The goal for this is to find the other factor that would multiply to x cubed plus 2x squared plus 2x plus 1. That top part's going to go on the diagonal part when we know how many diagonals we need. So if you're unsure of how many vertical pieces to draw in your boxes, you could look at the degree of the top. Remember, that's just the highest exponent you see there. So that's a degree 3. And I've got a degree 1 polynomial on the bottom. So if I subtract the degree of the top by the degree of the bottom, that will tell me how many of those vertical pieces to draw when I'm setting up my boxes. So from here, I'm going to take those terms on the top and put them along my diagonal. So this diagonal should add up to x cubed. That second diagonal should add up to 2x squared. This next diagonal should add up to 2x, and this last diagonal should just add up to 1. So as I'm going through this, the first place I start is always the top left box. That's just x cubed because there's only one term there, and I know that diagonal needs to be x cubed. The question you ask yourself to figure out what goes at the top here is, what would I have to multiply x by to get x cubed? And the answer to that would just be x squared. Now, once I have that, I could multiply x squared and 1 to get what goes in the bottom left part of this box. Because remember, that's how multiplication would work. You'd multiply the factors on the top and the right-hand side there. But this whole diagonal, I know needs to add up to 2x squared, not just 1x squared. So if I'm thinking about the coefficients, I've already got 1x squared. If I had another x squared here, then the diagonal would add to 2x squared and we'd be good. So I know that definitely has to go in that box. And then I ask myself the same questions. What would I have to multiply x by to get 1x squared? Well, the answer to that question is just x, or 1x. Then you can continue the process. X times 1 would just be 1x. And as I'm looking along this diagonal, I know those terms need to add to 2x. So if I've already got 1x, again, I would just need another 1x there. So what would I multiply x by to get 1x? Well, that's just 1. Notice that the constant, when I multiply 1 times 1, I get exactly what I was looking for. So the quotient when you divide these two polynomials is just whatever you get on the top there. So x squared plus x plus 1 would be my final answer there. Let's do a couple more. For number 2, it says algebraically show that x minus 2 is a factor of this polynomial right here. Well, if x minus 2 is a factor, that means I could rewrite this polynomial as x minus 2 times some other polynomial. So what we're going to try to do is we're going to take this polynomial and divide it by x minus 2 to see if we can actually get a nice polynomial out of that. So really, this is asking the same question as number 1 of setting up a reverse tabular method. So if this is the problem we're looking at, I could again start by just setting up my box. I'll put x and a minus 2 on the right-hand side there. And to figure out how many vertical lines to draw, I'm dividing a degree 3 polynomial, that's the highest exponent there, by a degree 1 polynomial, that's the highest exponent I see in the denominator. So there should be 2 vertical lines to draw. And that just ensures that I have enough spaces to put all of my terms along the diagonal. 6x cubed, negative 19x squared on the next diagonal, 16x on one of them, and the last one would just be a minus 4. Now, it's important to keep in mind that you have all of your degrees accounted for. This is a degree 3 term, degree 2, degree 1, and technically that last term is a degree 0. So Everything from 3 to 0 is accounted for here. If, for example, there wasn't an x squared term, I would just make sure to include a placeholder there. So I'll do the same process as the last one. I start with the top left box. That's got to be 6x cubed. And I ask myself, what do I multiply x by to get 6x cubed? Well, I know there'd have to be a 6 there as a coefficient. And to get an x cubed, I'd have to multiply x squared by just the x. So now if I've got a 6x squared on top, I could take that, multiply it to the -2, and get -12x squared there. Again, I'm looking along this next diagonal to continue, and I want the whole thing to add up to -19. Well, if I've got -12 already, if I added -7x squared to that, that would sum to -19. Now, if you're not sure of how to get that number, you could always do a quick subtraction problem off to the side and say, well, if I've got -19 and I subtract away -12, that's the same thing as -19 plus 12, or just -7. So that's how much more I would need to get up to -19. So always feel free to tackle that with subtraction in your calculator if you want. Now, I ask myself, what can I multiply x by to get -7x squared? I know it would need to be a -7, but also an x, because x times x is x squared. -7x times -2, remember a negative times a negative is positive, so 7 times 2 is 14. And I need that diagonal there to add up to 16. So instead of just 14, I would need an additional 2x, so that diagonal adds to 16. Now what times x gets me 2x? Just 2. And 2 times -2 is -4, which is what I wanted anyway. So this would show that x minus 2 is a factor, because this shows that this polynomial at the top can be written as x minus 2 times 6x squared minus 7x plus 2. So that would be enough algebraically to show that it's a factor. Number 3. What is the result when x cubed minus 4x squared plus 7x minus 28 is divided by x minus 4? Well, the process remains the same. Set up my boxes. I'm dividing x minus 4 into it, so that's going to go on the right-hand side. And I'm going to put that cubic polynomial, the x cubed, along the diagonal there. X cubed for my first term, -4x squared for the second, 7x, and -28. I'll start with the top left-hand side, and I'll keep going. What do I multiply x by to get x squared, or x cubed, excuse me? X squared would have to be there. And if I multiply x squared to -4, this would be -4x squared. And I need this diagonal to add up to -4x squared. But the problem is, I already have -4x squared, so I wouldn't need to add anything to that to make that diagonal add up to -4. So the only other possibility is there's a 0x squared there. So what would I multiply x by to get 0x squared? Well, you could just write 0. Or, if you want to keep it consistent, you could write 0x. And keep going with the multiplication. 0x times -4 is still 0, or I'm going to write it as 0x, just because I know these terms along the diagonal will probably have an x with it. But I want this diagonal to add up to 7. So I would just include a 7x there. 7 times x would be 7x. And 7 times -4 is -28. So the result would just be x squared plus 0x plus 7, but you don't really need that x to the first term in there since it's 0. So x squared plus 7 would be a perfectly acceptable answer there. Let's try one more. So this looks like it's going to be the chunkiest one here. Algebraically find the quotient of 6x to the 5th plus 4x to the 4th minus 6x cubed plus 14x squared minus 8 divided by 6x plus 4. There's actually one thing that I notice here as I'm looking at the numerator. There's an x to the fifth term, an x to the fourth, an x to the third, an x to the second, but there's actually no x to the first term there. And in order for this reverse tabular to work nicely, I need to include an x to the first term to make sure all of my degrees are accounted for, so I've got enough rows when I set up my boxes. So keep that in mind. You can set up the boxes the same way by knowing that I'm going to have two rows, one with 6x and one with 4. And then I'm dividing a degree 5 polynomial by a degree 1, because that's the highest exponent I see in the top and the bottom. So there should be 1, 2, 3, 4 vertical lines that I draw for my boxes here. You'll know if you did this correctly because you should have enough places for all of your terms in the numerator. 4x to the fourth, then negative 6x cubed, 14x squared, 0x, to make sure all my terms are accounted for, and negative 8. So now let's go through it. This is going to be the longest one so far. I could start with the 6x to the fifth again, and I ask myself, what do I multiply 6x by to get 6x to the fifth? Well, the coefficient's 6 already, so I don't need anything there. But an x to the fourth times x would get me x to the fifth. Now I could multiply x to the fourth times 4 to be left with 4x to the fourth in that bottom box there. And I want this diagonal to add up to 4x to the fourth. And I already have 4 there, so I wouldn't need to add anything to it. And I'll keep going. What would I have to multiply 0x to the 6x by to get 0x to the fourth? Technically just 0, but because I like all of my terms to be consistent, counting down in degree, I'll label it as 0x cubed. If I multiply that to 4, I'd get 0x to the third there, because 4 times 0 is still 0. And this diagonal now, I want to be equal to negative 6x cubed. So I'll just put a negative 6x cubed here, since I've got 0 in the other box. What would I multiply 6x by to get negative 6x cubed? Well, I would need a negative 1 for sure, and an x squared to multiply to the x. Negative 1x squared times 4 would just be negative 4x squared. I probably could have made these boxes a little bigger. And this diagonal here would have to add up to positive 14. Again, if you're unsure of what would add there, you could always do a quick subtraction problem off to the side. You could just take 14, what you want to get, minus what you got, negative 4, and find that that's 18 there. So I would need 18x squared in that top box. Now, what would I multiply 6x by to get 18x squared? Well, I know that 6 times 3 is 18, and to get an x squared, I would need another x there. And 3x times 4 is 12x. I want this diagonal to add to 0x, so I would need a negative 12x there to cancel it out. And 6x times negative 2 is negative 12x. And just to check, if I multiply negative 2 to 4, it ends up working out. So your final answer here, that part on the top, you could write as x to the fourth minus x squared plus 3x minus 2. It's very easy to forget a sign or count something wrong, so make sure you're being as careful as possible. And if you find that your numbers are too big, it's probably best to just erase and start over. You probably added something wrong or just forgot a negative.